We'll start in 1 minute. Today we'll continue with the practice final exam. Remember, there is a practice final exam on Newton, and it's highly recommended that you take that 2 or 3 times, because the real final exam is also on Newton. After today, I'll find some other things to review Wednesday, Thursday, and Friday. We might finish the paper practice final today. We got to this problem, number 18. Simplify, assuming variables represent positive numbers. So here we have the square root of 20x squared y times the square root of 8x to the 6th y to the 2nd. So in my opinion, I think it's easier to write it as a single square root and multiply the radicands. 20 times 8 is 160. X squared times x to the 6th is x to the 8th. And then y times y to the 2nd, we can go ahead and write it as y to the 3rd for now. And then just focus on simplifying this single square root. The largest factor of 160 that is a perfect square is 16. 16 times 10 is 160. X to the 8th is a perfect square because the exponent is even. And the largest factor of y to the 3rd that is a perfect square is y to the 2nd. So we'll rewrite this as the square root of 16 x to the 8th y to the 2nd multiplied by the factors that are left over, which are just 10 times y. And then we can simplify the square roots of the perfect squares. The square root of 16 is 4. The square root of x to the 8th is x to the 4th. One way to remember that, the square root has an index of 2. So when simplifying the square root of x to the 8th, we have x to the 8 divided by 2, or x to the 4th. The square root of y to the 2nd is y. And then we multiply 4x to the 4th times y times the square root of 10y. That is the simplified result. Okay, in the next example, we have an absolute value inequality. Solve this inequality. 5 plus the absolute value of 6 minus 2x is less than 11. And write the solution in interval notation and algebraic notation. First, we want the standard form. So subtract 5 from both sides, and we get the absolute value of 6 minus 2x equals 6. Sorry, less than 6. I was thinking of the next step. To find the endpoints, solve the absolute value equation. Solve the absolute value of 6 minus 2x is equal to 6. The solutions to this equation are the endpoints, and then after we find the endpoints, we'll test the intervals. So if the absolute value of 6 minus 2x is 6, then that means 6 minus 2x is either 6 or 6 minus 2x is negative 6. When we solve the top equation, we can subtract 6 from both sides, and we get negative 2x equals 0, or x equals 0. So x equals 0 is one of the endpoints. And then solve the other equation for x. If we subtract 6 from both sides, we get negative 2x equals negative 12. And then divide both sides by negative 2, we get x equals positive 6. Okay, so we divide the number line into 3 separate intervals with where the endpoints are 0 and 6. And then pick test points. In the first interval, pick a number less than 0. I'll pick x to be negative 1. And then in the inequality, replace x with negative 1. We have the absolute value of 6 minus 2 times negative 1. This is the absolute value of 8, because 6 minus 2 times negative 1 is 6 minus negative 2, or 6 plus 2. And then the absolute value of 8 is less than 6. That is false. So none of the numbers in that first interval are solutions. In the second interval, pick a number between 0 and 6. So I'll pick x to be positive 1. And then in the inequality, replace x with 1. We get the absolute value of 6 minus 2 times 1, which is the absolute value of 4, which is 4. 4 less than 6 is false. Sorry. True, of course. 4 less than 6 is true. Then in the third interval, pick a number greater than 6. So I'll pick x to be 7. And then the absolute value of 6 minus 2 times 7 is the absolute value of negative 8, which is 8, but 8 less than 6. This one is false. Okay, and we exclude the endpoints because the inequality is strictly less than. In order to include endpoints, we need the less than or equal. So we exclude the endpoints. Okay, so graphically, the middle interval, we put parentheses at the endpoints. And the algebraic notation is 0 less than x, which is less than 6. It's the algebraic notation. And then the interval notation is parenthesis 0, comma 6 parenthesis. This is the interval notation. So the algebraic and the interval notations, they mean exactly the same thing. And you can see how they resemble each other. And they are also consistent with the graph of the solution. Okay, in the next example, we have a right triangle problem. Okay, on this one, the hypotenuse of a right triangle is 3 times the length of one of the legs, and the length of the other leg is 128 feet. Find the lengths of the leg and the hypotenuse. Okay, let's just for an aid, let's draw a right triangle. And we're told the hypotenuse of a right triangle is 3 times the length of one of the legs. So I'll pick X to be the length of that leg that it's referring to, and then the hypotenuse is 3 times X. And the other leg is 128 feet. Then we just apply the Pythagorean theorem to this right triangle. So if we square the hypotenuse, the term 3x squared is equal to x squared plus 128 squared. When we square the term 3x, we get 9x to the second, which is equal to x squared plus 128 squared. Then let's subtract x squared from both sides, so we get 8x squared equals 128 squared. And then we can divide both sides by 8. So x squared equals 128 squared. I'm going to write it as 128 times 128 for now. And then we're dividing by 8. So eventually we just want to take the positive square root to get our solution. But we can simplify this a little bit. Let's see, 8 goes into 128 16 times. So 8 goes into 128 16 times. So we're just left with 16 times 128. As an equation, this has 2 solutions, but in the context of the problem, the only solution that we want is the positive one. So x is equal to the positive square root of 16 times 128. The square root of 16 is 4. And as we saw before, this the largest factor of 128 as a perfect square is 64. 64 times 2. So we get 4 times 8 times the square root of 2, or 32 times the square root of 2. The directions say round your answer to 2 decimal places. And so you can do that with a calculator, 32 times the square root of 2. Okay, the next example, simplify this expression. And in the end, we only want positive exponents. So inside parentheses, we have x to the second, y to the negative 3, over 6 times x to the negative 1 over y to the positive 3. And this is all raised to the second power. Well, for these types of problems, I usually like to simplify what's on the inside of the parentheses first. So we have an x to the positive 2 in the numerator, so I'll just leave that in the numerator. And in the denominator, we have a numerical factor of 6, so that stays in the denominator. And we already have y to the positive 3 in the denominator, so I'll put that in the denominator. And then in the original expression, the y to the negative 3 in the numerator, that's equivalent to having another y to the positive 3 in the denominator. And the x to the negative 1 in the denominator is equivalent to having x to the positive 1 in the numerator. We'll simplify inside the parentheses a little more. In the numerator, x to the second times x to the first is x to the third. And in the denominator, we have 6 times y to the sixth, because y to the third times y to the third is y to the 3 plus 3. And now we can apply the outer exponent. So in the numerator, we multiply the exponents to get x to the sixth. 2 times 3 is 6. If you think of 6 as 6 to the first, then we're multiplying the exponent 2 times the exponent 1, and we get 6 to the second. And then times y to the 2 times 6, or y to the 12th. And then finally, since we can simplify 6 to the second, which is 36, we get this simplified rational expression, x to the sixth over 36 y to the 12th. Okay, on the next page, completely factor the polynomial. 9x to the third minus 24x to the second y plus 16x y to the second. So the first step in factoring, if the greatest common factor is something other than 1, then factor that out. And we can tell by looking that the greatest common factor is just x. So factor x out, and then we're left with 9x to the second minus 24xy plus 16y to the second. Then we have to see if we can factor the trinomial inside the parentheses. Well, one way to go about it is to notice that this has the pattern of a perfect square trinomial. If you don't recognize that, you can still use the AC method. So if you multiply 9 times 16, you get 144. And then two integers that have a product of positive 144 and add up to negative 24 are negative 12 and negative 12. So that guarantees that we can factor it. And you might remember me saying a couple times that when you use the AC method to factor a perfect square trinomial, the two integers that satisfy the two conditions are always the same. So this is another hint that we have a perfect square trinomial. Okay, but even if you don't recognize that, we proceed with the AC method, transform the trinomial into a quadrinomial. So 9x squared minus 12xy minus 12xy. and so on. And then inside the parentheses, we factor by grouping. Out of the first two terms, out of 9x squared minus 12xy, we can factor 3x out. And then when we factor 3x out of those terms, we're left with 3x minus 4y. Then bring down the middle operator of subtraction. That reminds us to factor the negative of the greatest common factor of the third and fourth terms. So 4 is a factor and y is a factor, so we factor negative 4y out. And the other factor is 3x minus 4y. And finally, the complete factorization is x times the binomial 3x minus 4y times another binomial 3x minus 4y. Okay, the last hint that we've just factored a perfect square trinomial is that the two factors are identical. Okay, the next problem, a mixture problem. A chemist needs to mix a solution that is 11% iodine with one that is 47% iodine to obtain 800 liters of a mixture that is 22% iodine. Find the number of liters of 11% solution needed for the mixture. And then it says round to the nearest liter. So we need variable assignments. I'll pick x to be the number of liters that is 11% iodine. And I'll pick y to be the number of liters that is 47% iodine. And then we can write the two equations. One equation will just be will involve the number of liters. So x liters plus y liters has to add up to 800 liters. And then in the next equation, every term represents the percentage of iodine in those amounts. So x liters is 11% iodine, so our second equation is 0.11 times x. Y liters is 47% iodine, so we multiply this, we have 0.47 times y. And the mixture of 800 liters is 22% iodine, so here we multiply 0.22 times 800. Our variable assignment x represents the number of liters that is 11% iodine, and that's all we're supposed to find. So we want to solve this system of equations and determine the value of x. So we can always use the addition method, or we can always use the substitution method. Since we need to solve for x, I'll just use substitution, solve the top equation for y, and we get y equals 800 minus x. Then in the other equation, replace y with 800 minus x. So we have, when we do that, we get 0.11x plus 0.47 times 800 minus x equals 0.22 times 800. So in the next line, we have 0.11x. And then if we distribute this, we get 0.47 times 800 minus 0.47 times x equals 0.22 times 800. Okay, in the next step, we'll combine like terms, 0.11x minus 0.47x. That's going to give us negative 0.36x. And at the same time, let's go ahead and subtract 0.47 times 800 from both sides. So we have 0.22 times 800 minus 0.47 times 800. Notice that we can factor out 800. We can factor 800 out, and then, well, I'll do it in a couple of steps. So factor 800 out, we have 0.22 minus 0.47 times 800. And then in the next step, we'll divide both sides by negative 0.36. So we get x equals, but in the process, I'll simplify this. 0.22 minus 0.47 is negative 0.25 times 800 divided by negative 0.36. A negative divided by a negative is a positive. And notice that when after switching those to positives, we're just multiplying 1/4 of 800. 0.25 times 800 is the same as 1/4 times 800, which is 200. And then divide by 0.36. So you can use a calculator at any stage. Since I don't have a calculator, this is as far as I am going to take it. But then after you key that into a calculator, round it to the nearest liter or the nearest whole number. Okay, in the next problem, we have an equation of a circle. So it's nice that the directions say what we're dealing with. This is an equation of a circle, and we're supposed to write it in standard form. So we can get it into standard form by completing the square twice, once for x squared plus 8x, and a second time for y squared minus 2y. Okay, in the next line, we're going to create two perfect square trinomials. One that has x squared plus 8x as the first two terms, and the other perfect square trinomial will have y squared minus 2y. Okay, for x squared plus 8x, take half of 8 and square it. Half of 8 is 4, 4 squared is 16. So we add 16 to both sides. And then the other equation, y squared minus 2y, take half of negative 2, which is negative 1, square negative 1, which is positive 1, and add 1 to both sides. And then in the next step is the standard form. X squared plus 8x plus 16 is x plus 4 quantity squared. And then we add that to y squared minus 2y plus 1, which is y minus 1 squared. And then 47 plus 16 is 63. 63 plus 1 is 64. Okay, so this is the standard equation. So something you should be able to do, if you have the standard equation, then identify the x and y coordinates of the center. The center of the circle is the ordered pair, -4 for x and +1 for y. And the radius is the square root of 64, which is 8. Okay, and the next problem, number 25. Consider the line that passes through the point 2, -9, that is perpendicular to the line y equals 1/3 x plus 7. Two lines are perpendicular when their slopes are negative reciprocals. The slope of the given line is 1/3. So the slope of the perpendicular line is the negative reciprocal of 1/3. So I'll use the perpendicular symbol for the slope of the perpendicular line. The negative reciprocal of 1/3 is just -3. -3/1, but that simplifies to -3. And that line that's perpendicular with slope -3 passes through the point 2, -9. So we use the point slope form to start with. So we have y minus -9 equals -3 times x minus 2. The directions do say to get it into the y equals mx plus b form, slope intercept. But to start with, we use the point slope form, and now we'll just do a little bit of algebra and arithmetic. Y minus -9 is y plus 9. And on the right-hand side, -3 times the binomial x minus 2 is -3x plus 6. And then to get it into the slope-intercept form, now we can subtract 9 from both sides. And we get y equals -3x minus 3. So that is the slope-intercept form. On the next page, solve the equation 5 times the square root of x equals x minus 6. We want to solve for x. We see that x is inside a square root. So we can begin by squaring both sides. This 5 times the square root of x, quantity squared, equals x minus 6, quantity squared. And a reminder, when you square something, you multiply it by itself. So we have 5 times the square root of x times 5 times the square root of x. And x minus 6 squared is x minus 6 times x minus 6. On the left-hand side, 5 times 5 is 25. And the square root of x times the square root of x is the square root of x squared. On the right-hand side, x minus 6 times x minus 6, we have x times x, which is x squared, and then minus x times 6, or minus 6x, and then minus 6 times x again, and then finally negative 6 times negative 6 is positive 36. On the left-hand side, 25 times the square root of x squared is 25x. On the right-hand side, we get x squared minus 12x plus 36. This is just a quadratic equation, so we'll set one side equal to 0 by subtracting 25x from both sides. So 0 equals x squared minus 37x plus 36. We can use any method to solve this, but this factors really nicely. You can use the AC method. 1 times 36 is 36. Two numbers that have a product of positive 36 and a sum of negative 37 are negative 1 and negative 36. So the two factors are x minus 1 and x minus 36. This equation has two solutions, x equals 1 and x equals 36. But we have to remember that we're solving the equation with the square root. So we should check to see if those are solutions in the original equation. So we'll test x equals 1. In the original equation, replace every x with 1. So we get 5 times the square root of 1 equals 1 minus 6. The square root of 1 is 1, so 5 times 1 equals negative 5 is false. So positive x equals positive 1 is not a solution. Then test the other number, test x equals 36. This time we have 5 times the square root of 36. Set that equal to 36 minus 6. The square root of 36 is 6. 5 times 6 equals 30. This time we get a true statement. So the only solution is positive 36. Well, you might remember seeing examples of equations with square roots where all of the candidates are solutions. But you should always check to make sure. Okay, the next problem is a work problem. The equations have the form rate times time equals 1. So on this one, working together, Fred and Tom can clean the garage in 53 minutes. Working alone, Tom takes 19 minutes longer to clean the garage than Fred would take working alone. How long would it take Fred to clean the garage by herself? Okay, round to the nearest minute. So Frederica, maybe? Fred. We're supposed to find how long it takes Fred to clean the garage by herself. So pick a variable to represent Fred's time. So I'll pick T. You can pick any letter you want. So T is time in hours. Oh, sorry, time in minutes. And then we're told that Tom takes 19 minutes longer to clean the garage when working alone. So for Tom, time will have to be T plus 19. So we'll write down three equations, each having the form rate times time equals 1. When Fred works alone, Fred's rate times t minutes equals 1. Rate times time equals 1. When Tom works alone, Tom's rate times t plus 19 equals 1. And then when they work together, Fred's rate plus Tom's rate times 53 minutes equals 1. We're told in the first sentence that when they work together, it takes 53 minutes. Since we want to solve for t, we need an equation whose only variable is t. So in the next step, solve each of those for the rates. Fred's rate is 1 over t. Tom's rate is 1 over t plus 19. And when they work together, Fred's rate plus Tom's rate is 1 over 53. Okay, so the equation we want, replace Fred's rate with 1 over t. Add that to Tom's rate, which is 1 over t plus 19. And the sum of the two rates is 1 over 53. And then the next step, the least common denominator is 53 times t plus 19. To eliminate the denominators, we multiply every term on both sides by the least common denominator. When we multiply the least common denominator by 1 over t, the t's cancel, and we'll be left with 53 times t plus 19. And then multiply the next term, 1 over t plus 19 times the least common denominator. This time the t plus 19 factors cancel, so we're just left with plus 53t. And on the right-hand side, 1 over 53 times 53t times t plus 19. The 53's cancel, so we're left with t times t plus 19. This is a quadratic equation in the variable t. So we'll multiply things out and set one side equal to 0 and then solve the quadratic equation. On the left-hand side, 53 times t plus 19. Here I'll just write it as 53t plus 53 times 19. And then plus 53t equals t to the second plus 19t. And we'll subtract 106t from both sides. The left-hand side has a total of 106t. And then we'll subtract 53 times 19 from both sides. So we'll get 0 equals t squared minus 87t minus 53 times 19. I'll take it a step or two further by putting the numbers in the quadratic formula. So in this one, b is negative 87, a is 1, and c is negative 53 times 19. So in the quadratic formula, we have t equals the negative of negative 87, which is 87. The solution that we're going to want is the one that we get by adding, because the one that we get by subtracting is going to turn out to be negative. So I'll just write 87 plus the square root of the number negative 87 squared minus 4 times 1 times negative 53 times 19, all divided by 2. Okay, I'll leave the rest of that for you to do. You can always make sure that your answer makes sense. All right, let's look at the next problem. Solve the system of two linear equations. So here we have one equation is 2x plus 9y equals 28. And the other one is 9x plus y equals negative 32. So we can use the substitution method or the addition method. Earlier, we had a system of two equations where we used the substitution method. So let's try the addition method on this one. If you do want to use substitution, then it looks like it will be easier if you solve the bottom equation for y, and then in the other equation, replace y with negative 9x minus 32, and so on. But if we use the addition method, we can leave the top equation the way it is. 2x plus 9y equals 28. And then multiply every term on both sides of the bottom equation by negative 9. Negative 9 times 9x is negative 81x, and then minus 9y. And then negative 9 times negative 32 is going to be a positive number, and it's going to be positive 288. So you can verify if my arithmetic is correct. Negative 9 times negative 32, I get positive 288. And then when we add the equations, the variable y will be eliminated. 2x plus negative 81x is negative 79x. And 28 plus 288 is 316. And then when we divide both sides by negative 79, x equals 316 divided by negative 79. That looks like it's equal to negative 4. And then we need to find the y-coordinate. So we can use any one of the equations, but I'll use the bottom equation in the system and replace x with negative 4. So 9 times negative 4 plus y equals negative 32. Or negative 36 plus y equals negative 32. And then when you add 36 to both sides, we get y equals positive 4. So remember that the solution is an ordered pair. So you should write that the solution negative is the ordered pair negative 4, 4 is the ordered pair solution. Okay, we have less than a minute left. So I'll just tell you, tomorrow we'll continue working on the final exam sample. We'll probably most likely finish it, and then I will also send another email today with more problems that we can review for the final. But that's all for today, so go ahead and sign in for attendance. Have a good one. Shoot.